Okay, I'm going to pick up where I left off. I decided that I would not discuss the three-dimensional points because I found a video that does a good job of doing exactly that. But I do want to point out that when I plugged x equals 2 and y equals -3 back into my f of x, y equation to get my z, the last coordinate, I got -17. So I wanted to acknowledge that. So your point should be 2, -3, -17. Please see that video. All right, so here's another problem that is of interest. This is also in your notes. So we're trying to maximize or minimize this function. In order to do that, here's our 3 steps. One is to take the partials, f sub x and f sub y. So f sub x is 4x plus 0 plus, notice this has an x in it, so plus 2y times the derivative of that x, which is 1, plus 4 minus 0 plus 0. All right, f sub y, 0, no y, so 6y plus, here this has a y in it, I got to figure out how to take the derivative. 2x times 1 plus 0 minus 8 plus 3. All right, so now I am going to do step 2, which is to set your derivatives equal to 0. So 4x plus 2y plus 4 is equal to 0. And then here, I'm going to put the y's over each other. So 6y, here's plus 2x. 2x minus 8 is equal to 0. So there's step 2. Okay, you'll notice in my last example, I just had x in my equation. And here I just had y in my equation. But in this one, I have a combination of x and y. So we have to think back to what happened in Math 120. What did we do in order to eliminate one of the variables? So my guess is that you multiply one of the equations by a number. So I'll get rid of the x's. So I'll multiply the top and the bottom by -2. Okay, so if you forgot how to do that, please see your notes from Math 121. So this one, the top one yields 4x plus 2y plus 4 equals 0. And then if I distribute the -2 everywhere, right, and -2 times the 0 as well, -4x minus 12y plus 16, and -2 times 0 is 0. So now I can add these two together. Okay, so let me point out that if you have opposite signs, plus here and then minus there, you want to add. If you have the same sign, then you want to subtract. So if I add together, those two cancel. This gives me -10y plus 20 is equal to 0. And then you can, I don't know, add 10y to both sides. And plus 10y. Here I get 20 equals 10y. Divide by 10, divide by 10. So then y equals 2. All right, so that's really good to get to that particular point. If you have a combination, let me show you up here. If you have a combination of x and y, then that means that the x and the y's depend on each other. Now this is going to be different than the last example that I gave you. Okay, so please keep that in mind. Let me zoom out if I can so that you can see what's going on. If you have a combination of x and y, that means these two are dependent on each other. The last one I didn't have a combination. Okay, so here, this means that I can plug this y equals 2 into any equation that's equal to 0, any of them. So look, up here you had 2 equations equal to 0. I'm going to plug into this one. Okay, so let's see. We have 4x plus 2y plus 4 equals 0, and I'm going to plug y equals 2 right in there. So 4x plus 2 times 2 plus 4 is equal to 0. 4x plus 4 plus 4 equals 0. 4x plus 8 equals 0. Minus 8, make sure you're showing the work. 4x equals -8, divide by 4, divide by 4. So this yields that x equals -2. All right, so notice what happened. We had a y equals 2, and the x that goes with it is -2. So now we have our point. We have -2, 2, and then some z term. X, just like the video shows, please see that, okay, from the organic chemistry guy. X is -2, Y is +2, and now we need our Z. Okay, so now that we have our X and our Y, we can finally go back and revisit the original function. We want to go here. All right, let me fold this so that you can see. I want you really to be able to see where the substitution is coming from, right here at the beginning. So we want F of -2, 2. So let's plug -2 in for all the x's. So this is 2 times -2 squared plus 3 times 2 squared plus 2 times -2 times +2 plus 4 times -2 minus 8 times +2 plus 3. Whatever number that is goes right there, right? It is your Z term. Your Z is dependent on your choice for your X and your Y, all right? So notice, in both of these examples that I just gave you, I didn't tell you whether this was a max or a min. Okay, I didn't say anything about that. I just said something special happens here. Why? This 3-step process. Take the derivative, set your derivative equal to 0, solve for your variable, right? So if you look at this other example, look carefully, this is the first one. Take your derivatives, set your derivatives equal to 0, and then over here, there's step 3, solve for your variable. So the 3-step process is still applicable in all of those scenarios. Okay, let's look at one more problem, and I'll come back to both of those. So please make sure that you have your notes so that you can follow along with what I'm doing as we move forward. So what happens if we have f of xy? This is also in your notes. 1/3 x cubed minus 2y cubed minus 5x plus 6y minus 5. So here we go. We're looking for maxes and mins. How do we do that? Take your partial derivative, f of x and f of y. F of x, the derivative of this is just x squared. This doesn't have an x in it. This one does. Minus 5, no x, no x. F of y, this is -6y plus 6. There's that. Now notice this is the first case that I showed you where you just have an x in it in the first one and you just have a y here. So let me do step 2 so that you can see what's occurring. So we have x squared minus 5 equals 0, and we also have -6y plus 6 equals 0. Notice this only has an x. So I'm going to solve for the x. Right? I don't have to figure out how to eliminate one of your variables. That's unnecessary. So by adding 5 to both sides, I get plus 5. So then x squared equals 5. And then x equals plus or minus the square root of 5. Okay? Now here, actually I've made an error. Let me go back and clean that up. The derivative of this is not -6, but it's -6y squared, right? This 3 comes down, that makes that -6, and this should be 1 less power of y. So let me change this. So let's see, -6y squared plus 6 equals 0, like that. Subtract 6. -6y squared equals -6. Divide by -6, divide by -6. Y squared equals 1. So then y equals plus or minus 1. Okay? So again, you're only using that very first trick that I showed you because you only have an x in the first one and you only have a y in the second one. All right, so that means that these don't depend on each other, right? The x and the y are not dependent on each other. So the question then is, well, how do we group our x's and our y's? So if there's no dependency there, then we should be able to group it any way we want to. So what do I mean by that? So on the one hand, we have x equals positive the square root of 5, right there. And we also have x equals negative the square root of 5. And we also have y equals positive 1 and y equals -1. Okay? So again, there's no defined grouping. So I'm just gonna group that with that and that with that. So one of my points is going to be the square root of 5, 1, something, right? Another point is going to be the square root of 5, negative 1, something, right? Then I'm going to take this x value and do the same thing. So then my third point will be negative the square root of 5, 1, something. Right? I'm going to allow you guys to go back and finish this off for the z term. So negative square root of 5, negative 1, something. Doing a bad job with these stars. All right. So let me remind you, if you want these z values, then all you have to do is go back to the original function right here. Right? Plug your x and your y in there, and that should give you the corresponding z.